Welcome my dear student. So in this lecture series I am going to solve some of the interesting and challenging numerical problem from the physics book of Pathfinder. So let us start with this question where there is a bar supported with a block. So this is the block and there is a bar on the top of it placed on a frictionless plank. So this is the plank on which the bar and block system is placed. Now this system is connected with a spring attached to a nail driven into the plank with the help of a spring as shown in the figure. So coefficient of friction between the bar and the block is mu. Here the coefficient of friction is mu given. Now what maximum acceleration parallel to the spring can the plank be given preventing sliding between the block and the bar? Okay. So let us say the plank is given an acceleration. Let us say in this direction. A is the acceleration of the plank given. Okay. So with respect to plank reference frame, if I say this is the entire body which is not slipping. So if I say the mass of the bar and the block together is m. So can I say that with respect to plank reference frame, if I draw the plank and on this plank the spring is there and with that the mass m is attached. So in respect to the plank reference frame, with respect to the plank reference frame, the block has a pseudo force in this direction. What is that pseudo force? That should be equals to F should be equals to M into A. Pseudo force. Now the spring will elongate due to those pseudo force. So maximum extension will be the situation when the block and the plank comes to at rest. So initially what I say that work done by pseudo force, plus work done by spring. That is basically the change in kinetic energy. Now, what is change in kinetic energy? Initially, the system is at rest. Now, it will elongate up to the position where again the kinetic energy becomes 0. Why? Because that will give the maximum elongation. So, delta kinetic energy is final minus initial, that is 0 minus 0. Okay. So, what is the pseudo force work done? Pseudo force work done is m into A, that is the force, into x max, that is the maximum elongation. Spring force work done is half k x square, half k into xm square. So that is basically equals to 0. So from that what I am getting that the xm number, that is the elongation, maximum elongation of the spring, that should be equals to how much? 2 times of m into A by k. That is the maximum possible elongation of the spring. Now, maximum force acting because of the elongation is how much? Force acting by the spring is equals to k into x. Okay. So, correspondingly, what I can say, if the entire mass block system, so for this block and the system, let us say the mass is m. Now, it is being pulled by a force of equals to spring force is equals to k times x into m. That is the k max. So, that is the force maximum applied on the block. So corresponding to the what is the maximum acceleration possible? The maximum acceleration is equals to k times xm divided by mass. So that is how much? That is equals to 2 times of A. Why? Because I have already got the value of xm is equals to how much? Xm equals to 2 times of ma by k. So that means this is the maximum acceleration, and that maximum acceleration is the combined block system. So if there is no slipping, then this is the maximum acceleration of the system, and that maximum acceleration is only achieved whenever I can say there is no slipping. That means this is nothing but equals to our mu g. So if there is a 2 block system, so this is the block and this is another block. So that means if there is no sliding between these two, so there is a static coefficient of friction. And static coefficient of friction acting on this is equals to mu into mg. And correspondingly acceleration should be equals to mu times g. So that means 2 times of maximum acceleration, 2 times of A max, that is equals to our mu g value. So correspondingly what I can get the maximum acceleration A max, that is equals to mu g by 2. Okay. So this is the maximum acceleration with which the plank can move so that there is no slipping or no sliding between the bar and the block system. So between these two bodies there is no slipping, no sliding whenever the plank is moving with this much acceleration. So that is our answer. Hope you understand this. If you like this, please subscribe my YouTube channel. Thanks for watching.